Hidden beneath the surface of seemingly ordinary wetlands lies one of nature's most remarkable phenomena: peat bogs. These waterlogged ecosystems serve as perfect preservation chambers for archaeological treasures while simultaneously functioning as vital carbon sequestration systems in our fight against climate change. Join us on a journey into these enigmatic landscapes that uniquely connect our past with our future, preserving ancient human remains with incredible detail while storing more carbon than all the world's forests combined. Peat bogs create a remarkable preservation environment through a unique combination of acidic, cold, and oxygen-poor conditions that effectively halt normal decomposition processes. This extraordinary chemistry has preserved human remains for thousands of years in the form of bog bodies. The most famous of these is Tollund Man, discovered in Denmark in 1950. His facial features remain so incredibly well preserved after 2,400 years that investigators initially believed they were dealing with a recent murder victim. The preservation is so thorough that scientists can often determine what these individuals ate for their final meal. Analysis revealed that Tollund Man consumed a gruel made of barley, flax, and several wild plants before his death. Many bog bodies retain their hair, fingernails, and even clothing, providing archaeologists with unprecedented insights into ancient societies that would otherwise remain mysterious to us. The chemical processes behind the remarkable preservation capabilities of peat bogs are fascinatingly complex. Sphagnum moss creates a highly acidic environment and produces compounds called sphagnan that bind with nitrogen and effectively inhibit bacterial growth. Meanwhile, the waterlogged nature of bogs creates an oxygen-free environment that prevents aerobic decomposition processes. Naturally occurring compounds like humic acid actually tan the skin of bog bodies through a process remarkably similar to leather making. This natural tanning process transforms skin proteins into more stable compounds that become highly resistant to bacterial breakdown. It's this perfect storm of preservation conditions that allows organic materials to remain intact for millennia rather than decomposing within weeks or months as they would in normal environments. While bog bodies capture our imagination, peat bogs have preserved numerous other archaeological treasures that provide unparalleled windows into ancient civilizations. Wooden structures that would normally decay within decades have survived for millennia in these environments. In Ireland, numerous wooden trackways dating back to 2000 BCE have been discovered, revealing ancient transportation routes that our ancestors constructed across these wetlands. These sophisticated engineering projects demonstrate technological capabilities we might otherwise never have known about. In Scotland, researchers have discovered bog butter, dairy products that were buried in bogs either for preservation or ritual purposes, still intact after centuries. These discoveries allow archaeologists to piece together not just how ancient peoples died, but how they lived, traveled, and what they ate, providing a more complete picture of past civilizations than almost any other archaeological context. While peat bogs cover only about 3% of Earth's land surface, they store a staggering 30% of all soil carbon, twice as much carbon as all the world's forests combined. This makes them one of our planet's most efficient natural carbon sinks at a time when carbon sequestration has never been more important. The extraordinary carbon storage capacity of peat bogs comes from their unique formation process. As plants die in these waterlogged environments, they don't fully decompose. Instead, they slowly accumulate as peat, effectively locking away all the carbon they absorb during photosynthesis. Some northern peat bogs have been accumulating carbon continuously for over 10,000 years, since the end of the last ice age. To put their efficiency into perspective, a single hectare of healthy peat bog can store up to 2,000 tons of carbon, which is equivalent to the emissions produced by approximately 1,400 transatlantic flights. However, this carbon storage is precarious. When bogs are drained for agriculture or harvested for fuel, they release their stored carbon into the atmosphere, transforming from carbon sinks to carbon sources. The carbon accumulation rate in peat bogs varies significantly depending on climate, vegetation type, and hydrological conditions. Under optimal conditions, peat can accumulate at a rate of 0.5 to 1 millimeter per year. While this may seem modest at first glance, when considered over geological timeframes, this slow but consistent carbon capture has made peat bogs crucial players in Earth's carbon cycle for millennia. Climate scientists are increasingly recognizing peat bogs as critical allies in our climate change mitigation strategies. Recent research suggests that protecting existing peatlands from drainage and degradation would be more cost-effective for carbon management than many engineered carbon capture technologies that are currently being developed. Additionally, restored peatlands continue to sequester carbon indefinitely, unlike forests, which eventually reach carbon equilibrium as they mature. This gives peatlands a unique advantage in long-term climate mitigation planning. Peat bogs host highly specialized plant communities that have adapted to their harsh, nutrient-poor conditions. The most iconic of these are sphagnum mosses, which create and maintain the acidic environment that characterizes bogs. These remarkable mosses can hold up to 20 times their weight in water, functioning like natural sponges that regulate water flow and prevent flooding in surrounding areas. Perhaps most fascinating are the carnivorous plants that thrive in bog environments. Species like sundews and pitcher plants have evolved to capture insects as an alternative nitrogen source. Since bog soils are notoriously nutrient-poor, the sundew uses sticky tentacles that curl around prey when triggered, while pitcher plants create elaborate traps filled with digestive fluids that drown insects before absorbing their nutrients. These adaptations demonstrate the extraordinary evolutionary pressure of bog environments and the creative solutions that organisms develop to survive in them. Some bog-dwelling organisms have developed truly extraordinary adaptations to thrive in these challenging environments. The four-toed salamander, for instance, has evolved to lay its eggs in sphagnum moss rather than in water, an unusual behavior for amphibians. Certain fungi have adapted to thrive in highly acidic conditions that would kill most other species. The biodiversity of peat bogs extends far beyond these examples. Specialized insects like the large heath butterfly depend entirely on bog habitats, laying their eggs exclusively on cotton grass that grows in these environments. The microbial communities in bogs include extremophiles that have evolved to metabolize compounds that most organisms cannot process. These microorganisms represent potential sources of novel enzymes for biotechnology applications, from biofuel production to pharmaceutical development. Additionally, peat bogs function as natural water filtration systems. The sphagnum moss that dominates many bogs has remarkable ion exchange properties that can remove pollutants from water, helping maintain water quality in surrounding watersheds. Peat bogs have influenced human culture for millennia in profound ways. In Ireland, where bogs cover approximately 20% of the landscape, peat, locally called turf, has been harvested for fuel for centuries, becoming integral to cultural identity and traditional ways of life. Archaeological evidence suggests that ancient Celtic peoples may have considered bogs to be sacred places and possibly gateways to the spirit world, which might explain why many bog bodies appear to have been ritual sacrifices rather than ordinary burials. These cultural connections demonstrate how deeply intertwined human societies have been with these unique landscapes throughout history. The relationship between humans and peat bogs continues to evolve as awareness of their ecological value grows. Traditional peat harvesting practices are being reconsidered in light of climate concerns in countries like Scotland and Ireland, where peat has been a cultural resource for generations. Community-based peatland restoration projects are creating new economic opportunities through ecotourism and carbon offset programs, demonstrating how cultural heritage can be honored while embracing more sustainable relationships with these ancient landscapes. Today, peat bogs face significant threats from multiple directions. Drainage for agriculture, peat harvesting for horticulture and fuel, and the accelerating impacts of climate change all threaten these valuable ecosystems. When peat bogs are drained, the peat oxidizes and releases carbon dioxide, transforming these carbon sinks into carbon sources. The scale of this problem is massive. In Indonesia alone, drained peatlands release more carbon annually than many industrialized nations. However, conservation efforts are growing as scientists and policymakers recognize the ecological importance of peat bogs. Rewetting drained bogs can halt carbon emissions and eventually restore their carbon capturing function. These restoration efforts can also provide habitat for rare species and protect archaeological treasures still waiting to be discovered beneath the surface. Peatland conservation is gaining momentum internationally through agreements like the Ramsar Convention on Wetlands and initiatives like the Global Peatlands Initiative. These efforts recognize that protecting the world's peat bogs requires coordinated action across national boundaries, as the benefits of healthy peatlands, from carbon storage to biodiversity conservation, are truly global in scope. Despite the challenges, there are inspiring success stories in peatland restoration that provide hope for the future. In the United Kingdom, The Great Fen Project aims to restore 3,700 hectares of peatland, creating a vast connected landscape that will store an estimated 325,000 tons of carbon dioxide annually when complete. In Indonesia, after devastating peatland fires in 2015, the government established the Peatland Restoration Agency with the ambitious goal of restoring 2.5 million hectares of degraded peatlands. These large-scale projects demonstrate that with proper management and restoration techniques, damaged peatlands can recover their ecological functions. Restoration typically involves rewetting drained areas by blocking drainage ditches and reintroducing native vegetation, particularly sphagnum moss species that are essential for peat formation. While fully functioning peat bogs can take decades or even centuries to recover completely, the carbon benefits begin almost immediately when oxidation is halted by rewetting. This makes peatland restoration one of the most effective nature-based solutions for addressing climate change while simultaneously providing benefits for biodiversity and cultural heritage preservation. Peat bogs represent one of nature's most remarkable intersections of past and future, preserving our history with extraordinary fidelity while potentially helping secure our climate future. These overlooked ecosystems, covering just 3% of Earth's land surface yet storing twice the carbon of all forests combined, demonstrate nature's ingenious solutions to both preservation and carbon sequestration. From the perfectly preserved faces of ancient bog bodies to the specialized carnivorous plants and salamanders that have evolved unique survival strategies, peat bogs offer endless scientific discoveries. As we confront the dual challenges of cultural heritage preservation and climate change mitigation, these waterlogged landscapes emerge as crucial allies. The fate of peat bogs will impact not just local ecosystems but global carbon cycles. By protecting existing peatlands, restoring damaged ones, and developing sustainable relationships with these environments, we honor both our past and future. The ancient Celtic peoples who once viewed bogs as sacred gateways between worlds may have understood something profound about these landscapes. They connect us across time in ways few other natural features can. Thanks for watching. Please like, subscribe, and hit the bell icon for updates. Your feedback is appreciated. We hope to see you again.